In this session, we'll be looking at regression analysis inside of Alteryx, specifically how to build a linear regression model, run a stepwise regression. We'll then look at how we can apply that model to our data, how we can score the records, and we'll also look at what other regression model techniques are available inside of Alteryx. We'll be using baseball statistics from the MLB, Major League Baseball. Note that I have already run this workflow. So as I click on the Browse tool here, we can see our 30 MLB teams and their associated statistics. The variable that we're interested today that we want to predict is R_G, or runs per game. When performing predictive modeling, the first step is not often predictive at all. Rather, we should want to investigate our data. Alteryx has a variety of investigation tools inside of the data investigation category. Today, we're going to look at just the association analysis tool. This tool shows correlation coefficients. Configuring the tool allows us to choose a target variable, in this case runs per game, and the numeric variables that we'd like to correlate. From the R output, we can see which variables are most statistically significant. We can also see the strength of their relationship, the association measure, and we can see the full correlation matrix. Using the association analysis tool is just one way to determine which variables are appropriate for our predictive model. The second output is interactive. This allows us to examine an interactive correlation matrix. Selecting a correlation will then display a scatterplot of those values. In this regression training, we'll show how to use a linear regression tool. As you can see, the configuration is straightforward. We're asked for a model name, which here we've called linear runs per game, as well as that target variable that we want to target. We then have to select the variables that we'd like to pass through the model. Now, our investigation of the data using the analysis tool suggested a variety of variables for us to pass through this linear regression, including RBI, runs batted in, on-base percentage, slugging, and their combination, OPS. So we've selected those to pass through the linear regression. From the regression tool, we can put a browse tool after the R, or report, output. This lets us view the standard statistics for the model. These include coefficients, p-values, and R². As we examine these statistics, at this point we could go back to the regression tool and choose new variables for the model. Or we can accept the model and run a stepwise process. To run a stepwise, we simply pass the linear regression output from the O into the stepwise regression tool. We also pass the original data from the baseball data input into that stepwise regression. We run the workflow and review the data again in the Browse tool. There are additional ways to configure the stepwise, which you can read about by right-clicking on the tool in the menu and selecting Help. Examining the stepwise report will help us decide if the model is better or worse than the linear regression model. We can see here that the stepwise has eliminated all of the variables except for the RBI. So, how do we know which model to use? Built into our predictive category, we have a nested test tool. This tool helps us compare the two models. We pass both of the model O outputs into the tool, as well as the original data. For this nested test to work, one of the models needs to contain a subset of the variables from the other model. Since our stepwise only contains RBI, we can use the nested test approach. The nested test approach creates a statistic measuring if the larger model is statistically better than the smaller model. If that's true, we find a large p-value, i.e. one greater than 0.1. As you can see here, the model is indeed large, at 0.5. Therefore, we can reject the null hypothesis here that the larger model did not add value. Consequently, our larger the model, the linear regression did add value, so to move forward, we would use the model from the linear regression. Now that we have decided on the model, we can use a score tool to apply the model to the data points that we have. These data points may be the data we pass through the model, or they may be a holdout sample from that data. They may even be a new but comparable data set. Again, we have the option to configure this model. Did we oversample? Did we do a log transformation? And maybe we can also add a confidence interval, which we'll do here. The final browse tool allows us to see the results, the actual runs per game, RG, and the model's predicted runs per game. Here we've also generated 95% confidence upper and lower bands. At this point, we could even use a formula tool to calculate error by taking the score value and subtracting the actual runs per game. We could even then assign the values into buckets, whatever works for you to best assess the model. In addition to the linear and stepwise regressions, Alteryx also allows you to perform other regression models. The first to highlight is the logistic regression, which will also assess probability, but on a binary string target variable such as a yes/no or live/die. Decision tree and forest models can also be utilized for either type of target variable. Count regression, gamma regression, boosted and spline models are also other types of regression models that we can perform in Alteryx.